Have you ever heard of a NASA project so secret that even the scientists themselves have to stay silent? A strange name, STVAR, is quietly mentioned in internal documents. No official press release, no public conference, just scattered fragments leaking across the internet. And all of them are gradually revealing something much bigger. Could it be an extraterrestrial research program? A project on advanced space technology? Or something that goes far beyond our imagination? What is NASA STVAR? This is not an ordinary video. This is a journey into curiosity, one of the most powerful driving forces of humankind. And now, let's begin that journey together. While most NASA projects are named after mythology, astronomical phenomena, or specific scientific goals, such as Artemis, the moon goddess, Voyager, the traveler, or JWST, James Webb Space Telescope, STVAR is a strange exception. There is no official press release. It doesn't appear on NASA's homepage. It's absent from public financial reports submitted to the US Congress. STVAR only surfaces in scattered fragments of leaked technical documents or on internal project lists, with no clear explanation. Some experts speculate that STVAR might stand for Space-Time Variable Anomaly Research, based on brief descriptions of anomalies and the analysis of irregular data from specific regions in space. This possibility is not without foundation. If this assumption is correct, STVAR may be tied to advanced research into the structure of the universe, regions with abnormally high energy densities, distortions in space-time, or even phenomena beyond the scope of modern physics. One striking detail: there is no publicly named team responsible for STVAR. In typical projects, NASA clearly states the leading unit, for example, the Jet Propulsion Laboratory, JPL, or the Ames Research Center. But with STVAR, nothing. Carl Sagan once said, "The absence of evidence is not evidence of absence." Just because NASA hasn't made STVAR public doesn't mean the project doesn't exist. On the contrary, it might suggest this is a program of exceptionally high sensitivity, potentially linked to national defense or technologies beyond what the public is currently ready to grasp. At a 2021 conference, an anonymous theoretical physicist mentioned a number of unexplained anomalies near Lagrange point 2. Coincidentally, the same area where astronomy missions like James Webb are operating. And in a leaked document, a brief line was flagged. STVAR analysis, L2 probe telemetry flagged. This has sparked theories that STVAR might be a system monitoring anomalies at critical locations in space. Looking deeper into the name, STVAR is also a word in Serbian-Croatian, meaning thing or object. Could this be a clever wordplay by the project team? A veiled reference to something yet to be defined? Or merely a random coincidence? There's an unwritten rule in intelligence. The things kept most secret are often hiding in plain sight. If STVAR truly is a public-facing project in disguise, then not knowing what it really is might be the most important part of its design. Theories surrounding STVAR. From conspiracy to quantum technology. When a project like STVAR emerges with such an unbelievable level of secrecy, the online community inevitably begins to dig, piece things together, and propose a multitude of theories. Some sound downright crazy. Others are persuasive enough to make even scientists stop and think. The most discussed theory on forums like Reddit, Stack Exchange, and phys.org subforums is this: STVAR may be related to simulating the universe using quantum algorithms. This idea isn't new. In 2003, philosopher Nick Bostrom wrote, "If a civilization becomes advanced enough to simulate a universe, then the probability that we are living in a simulation is extremely high." That theory hasn't stayed within the realm of philosophy. It has appeared in serious scientific publications, and today, quantum computers are reaching the point where they can simulate extraordinarily complex phenomena of the real universe. If STVAR is part of a project that simulates the space-time structure at the quantum level, its purpose could be to test the laws of physics under simulated conditions, such as at the birth of the universe, or in areas of extremely high matter density, like near black holes. This might explain why information about STVAR is classified, because it touches the limits of both theoretical physics and defense technology. A second theory is bolder, yet not without believers. STVAR is an effort to study the possibility of interacting with parallel realities. It sounds like science fiction, but the many worlds interpretation of quantum mechanics has long posited that every decision, every quantum interaction, could split the universe into multiple branches. If we could detect or even interact with anomalies in space-time, then connecting between realities is theoretically possible. One leaked document mentioned the phrase, interference mapping across state variance fields. This has led many to believe that STVAR is not just observing, but attempting to intervene in regions of space with unstable properties. In other words, experimenting with the very fabric of reality. There is also a more cautious hypothesis that STVAR is a space monitoring system designed to detect unidentified forms of technology, much like how the military tracks strange signals from foreign satellites. The key difference here: STVAR doesn't appear to be monitoring artificial devices, but instead seems focused on physical anomalies, the kind that no one has claimed ownership of, yet might originate from somewhere else. In a 2020 interview, Dr. Michio Kaku said, "If an extraterrestrial civilization wanted to communicate with us, they wouldn't use radio waves. They would use the structure of space-time itself as a tool." If that's true, then STVAR might just be humanity's first gateway to this new form of communication. Many remain skeptical, arguing these are just baseless speculations. But we must remember, before Einstein proved that mass could bend space, that idea too was dismissed as science fiction. Scientific imagination, when fueled by real-world data, has always been the birthplace of great discoveries. Setting aside sci-fi, understanding STVAR through a scientific lens. Setting aside speculative theories to understand STVAR scientifically, we must place everything in real-world context. NASA is an organization whose core mission is to explore space, expand scientific knowledge, and develop technology. Therefore, if STVAR truly exists, then despite its secrecy, it must serve a specific research or technical objective. A reasonable first approach is this. STVAR could be a project focused on observing and analyzing anomalies in data from space, such as gravitational waves, unexplained electromagnetic signals, or fluctuations in gravitational fields in particular regions. In 2015, LIGO made the first detection of gravitational waves, a groundbreaking discovery predicted by Einstein back in 1916. To detect them, scientists used ultra-sensitive instruments capable of measuring changes smaller than the width of an atom. STVAR could very well be an extension of this technology, focusing on phenomena we've never encountered or cannot yet explain with current data. A research team at Caltech once published a report on unusual disturbances in data collected from the Lagrange Point 2 area, the same region where major telescopes like the James Webb operate. These disturbances didn't align with current physical models. If STVAR was designed to analyze such anomalies, then it is a purely scientific endeavor, but one that lies at the outer edge of human knowledge. Another more practical hypothesis is that STVAR is a fault detection system for next-generation space sensors, This may sound mundane, but for space missions that last decades, like Voyager or Artemis, even a small error can lead to catastrophic consequences. Modern sensors are increasingly complex and can be affected by cosmic radiation, high-energy particles, or even quantum effects if the device is too sensitive. As aerospace engineer Paul Anderson, NASA JPL, once said, "A spacecraft, once it leaves Earth, must make decisions on its own. If its instruments mistake a celestial object for a sensor error, the entire mission could fail." With that standard, STVAR could be a reliability check platform for sensor systems, especially in unexplored space environments. One detail few notice is that in recent years, NASA has been deepening its collaboration with DARPA, the U.S. Defense Research Agency. Projects like the X-37B, an unmanned spacecraft operating secretly for months, clearly show how space technology is increasingly blending civil research with strategic purposes. If STVAR is a system designed to monitor physical phenomena that might threaten satellite safety, then keeping it classified makes perfect sense. Additionally, we cannot ignore the possibility that STVAR is related to big data analysis in space. With massive volumes of data pouring in from telescopes, observatories, and satellites, NASA needs a system intelligent enough to detect anomalies. STVAR could integrate AI, machine learning, and physical model analysis to identify what doesn't fit. And that's precisely where real science begins. Physicist Richard Feynman once said, "Science is not a collection of facts. It's a process of investigation." If we view STVAR through that lens, then even though we may not know exactly what it is, we can infer that it's a tool for investigation, for asking the right questions, and for not missing the secrets the universe is still hiding. Science is often seen as a dry field, ruled by numbers and theories. But behind every research endeavor, every space project, whether public or secret like STVAR, are people filled with doubt, desire, and curiosity. I still remember a quote from Dr. Brian Greene, author of The Elegant Universe. He once said, "We don't just study the universe to understand it. We study it to understand where we are within it." STVAR, with its cold and anonymous name, might actually be a very human whisper. What else don't we know? I first saw the name STVAR on a small forum where former NASA engineers would share old documents. Someone had posted a short piece of code titled STVAR Anomaly Test Pattern, Revision 3. It wasn't a fancy diagram or an academic paper, just a few lines of code, a few data parameters. But there was something in that simplicity that gave me chills. Because behind those lines of data was someone's effort, a researcher who may have stayed up all night coding, testing, and then embedding it into a system. They didn't need fame, didn't appear in headlines, but they did it anyway. Because they wanted to know what was happening out there, in the dark universe where no one knows what comes next. There's an interesting story from the 1970s. When Voyager 1 was launched into space, scientists attached to it a golden record, containing images, sounds, and greetings from Earth, sent to alien beings who might never have heard of us. Among the recordings was the sound of a woman laughing. The project lead said, "If aliens hear it, at least they'll know humans once knew how to laugh." STVAR might be a scientific tool, but it could also be a message from small beings on a small planet saying, "We are trying to understand something greater than ourselves." Curiosity isn't a flaw, it's instinct. It's what took humans to the moon, what sent probes beyond the solar system, and now, maybe, what's pushing us to experiment with the very fabric of time. Of all the definitions of humanity, I think the best comes from Carl Sagan. We are a way for the cosmos to know itself. And STVAR, if it truly is part of that journey of discovery, then it's not just technology. It is a reflection of perseverance, of the endless why that humanity never stops asking. An old NASA engineer once wrote in his journal, "We don't do this to be remembered. We do it because if no one does, then no one will ever answer the question." The question may not yet be revealed. The answer may take years to come. But it is the act of continuing to ask, as STVAR might be doing, that keeps the flame of exploration within us forever burning. We're drawn to STVAR, not just because it's secretive, but because it touches something deeper within the human mind, the limits of what we know. Humankind has come a long way since believing Earth was the center of the universe. We've sent spacecraft beyond the solar system, mapped the cosmos, and detected gravitational waves. Yet the more we understand, the more we realize we're merely skimming the surface of a vast ocean of knowledge. STVAR, though no one knows exactly what it is, seems to stand at that boundary, between what is known and what is still unknown. It raises a profound question. Are we even capable of understanding everything the universe is trying to tell us? Dr. Neil deGrasse Tyson once said something deeply thought-provoking. The problem is not that the universe lacks answers, it's that we haven't asked the right questions. That's why STVAR is so intriguing, because it makes us wonder. Maybe the question has already been asked. Maybe someone, somewhere, has found something that defies our current logic and is quietly trying to make sense of it. There's a philosophical theory called the cognitive limits of humanity. It suggests that there may be concepts, phenomena, or realities that the human brain, with its current biological structure, simply cannot comprehend, just as a dog cannot grasp the theory of relativity. If STVAR is related to space-time anomalies or data that falls outside our models, it might be the first sign that we've begun to brush against that limit. And that's not frightening. On the contrary, it's inspiring. As Stephen Hawking once said, "The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge." The allure of STVAR also lies in this. It doesn't give us immediate answers. It forces us to endure ambiguity, to live with uncertainty, something serious science always demands of us. Unlike neatly packaged theories, STVAR, in its current state, is an undefined bone fragment, a rough draft the universe hasn't finished writing. And for that very reason, it attracts those unafraid of getting lost in the labyrinth. Those who believe that the path to discovery isn't always lit. In the history of science, many breakthroughs began with chasing what, at first, seemed absurd. Einstein once imagined a thought experiment about chasing a beam of light, which led him to develop the theory of relativity. That began with pure imagination, and who knows, maybe STVAR started with something just like that. A small question posed somewhere in the quiet corridors of a research facility. If that's the case, then what makes STVAR most compelling isn't its secrecy, or its ties to advanced physics or cosmic conspiracy. It's that it gives us a reason to keep asking, what if? The question that took us from cave dwellers to moonwalkers. And in the very moment we still feel a thrill from an unfamiliar acronym like STVAR, it means we still retain the ability to look up, as our ancestors once did, and ask, what else is out there?